where we stopped last time. Last semester, or let me say the last block, we did calculus. That was, we were able to do integration and then differentiation in the last block. This block is a continuation of what we did, but here we are just using adding something to what we did with regards to the integration last block. So we are going to do the further integration. Now there are two ways we are going to do the further integration. We are going to do integration by pass and then integration by substitution. These are the two things we are going to do, and then we'll look at example each, and then we'll move to the next one. There are some basic rules we need to understand about the integration by pass here. If a function is given to you, if a function is given to you in the product form, and you know that we have to differentiate it using the product rule. And you might not forget that the product rule, let me come, if I can create a new page here. Okay. So if we are saying that if you have a function, let's say y is given to you as uv, okay, and you are being asked to differentiate, okay, this, because this is multiplying, you definitely have to use the product rule. Now, what does the product rule say? The product rule says that when you have a function like this, then you have to hold one constant and differentiate the other. Then you add it to the rest. So what you are going to do is that you are going to hold v constant, then you differentiate our dy So when you hold v constant, you are differentiating the u. So you are going to get du over dx. Okay. Then remember, u is a function of x. V is also a function of x. So plus, you also differentiate. Here you are going to now hold the u constant, and then you differentiate the v with respect to x. And this is what we call the product rule. The product rule. Okay. Now, integration by part, we are going to derive how the integration by parts looks like. Okay. So when you have something like this, it means that y is equal to this u. So we can equally say that let u here, uv here, to be equal to, our v du over dx, then plus our u here, our dv over dx. Okay. Then I want to you have to use I want to use I want to integrate this. After finding the product rule, I have to integrate this. Okay. So by integration, I mean that I have to apply integral here and then apply integral here. So if you apply integral here, then then your function is going to now look at u v here to be equal to v. So we are going to have v, then du. Sorry. We are going to have du, then plus here we are going to have u, then dv. Okay, after taking the integral, this is what you are going to get. Okay. Now, when you get this, when you have this, then you can now okay. So this, yeah, so this one here, du dv here, yes, we can shorten it. So I will have to add this one there. And then this one too, I will also have to add this. Okay. So if we see the du here, it is simply telling you that you are differentiating the u respect to x. And if you also see v here, you are also saying that you are going to differentiate v respect to x. So we are just taking the integral of both sides. Okay, so if you take the integral of both sides, then I want to make du, this one the subject. So integration by parts, the formula says that if you make du, this one the subject, u dv the subject, it is going to give you this. So this one will come. You are going to get u v here minus the integral of v du here. Integral of v du here. So this is the format, or this is the format of the integral by parts. The integral by parts. So if you want to integrate by using parts, then we need to find the value of u. We also need to find the value of v. And then we need to find the value of v du together, and we subtract them together. And that will give us the integration by parts. Okay. So we need to look at example and how we can use it to solve the integration by parts. So first, let's look at this example. We have 4x bracket x plus 4 raised to the power -9. So let me add another thing. Okay. Let me copy this. So I have, what is the question? The question says, you should integrate by parts using the, so we have 4x bracket x plus 4 raised to the power 9 raised to the power 9. Okay, raised to the power 9. So we are asked to integrate this one by parts. So what the first thing what you need to do is that you need to say remember we have two variables. We have v and u. V and u. So you have to say that let u is to be equal to 4x. And then we also have vu, and let dv to be equal to my x, the one in the bracket, plus 4 plus 4. Okay, so that when I differentiate du, over the x, which is the same as my du, I am going to get 4. Okay, so my du has been found. Remember, we are using the formula, this formula. That's the formula. Remember, we are going to use this formula. So we need to find the value of u. We need to find the value of v. We need to find the value of du. Okay, so we found what du is. We need to find the value of v. Okay, we need to find the value of v and then u as well. Okay, so that is what we are going to look at. So let's move on to look at okay, so let's move on to look at where is it. So this is u is equal to this, the u is equal to this. So we are now going to look at dv. So our dv is this function. So what we are going to do here is that we are going to integrate our dv here in order to get our v. So what we are going to do is that we are going to apply the integral sign to this. So we are going to get the integral of dv, to be equal to the integral of x plus 4 then dx. So that if we integrate this function, this integral here will cancel our integral here. So we are now having our v stand alone. So v is now equal to, now if we integrate this, remember how we integrate. The integral means that you are adding 1 to the exponent and you divide by the exponent. Okay, so when you integrate this one, we are going to get 1 over 2, then 1 over 2, then you have x squared plus 4x. Okay, so when you integrate it, that is what we are going to get. Okay. Sorry. This is supposed to be raised to the power 9. So this one, let me come. Just a minute. Because we are saying that once our u is equal to 4x, then our v, the v is equal to the whole of this. So we are supposed to have this here over 9. Now we now have to integrate this one. Now, if you integrate this one now, this one, the new one here, this d here will cancel this d, so that we can integrate this one. And the integral of this one says that you are going to get add 1 to the exponent and divide by the, so you are going to get x squared plus 4x plus 4x. Then we divide by our 10, because if you add the 1 to the exponent, we are going to get 10. We are going to get 10. We are going to get 10.
So how come it's x squared plus 4x?
Oh, just a minute. We are integrating. Okay, so this is yeah, so we are going to get this. Sorry. We are going to get this 10. Then you divide by 10, because this is all in the bracket, and we are differentiating the function you are differentiating the function together. Yeah, so we are going to get v to be equal to 1 over 10 bracket x plus 4 raised to the power 10, x plus 4 raised to the power 10. Okay, right, so this is what we are going to get. So you've been able to find your v, you'll be able to find your du, and you'll be able to find your u. Now the formula says that your you are going to get, this is the formula, u dv is equal to uv minus the integral of v du. Now, what is u? The u, we said let u is equal to 4x. So we decided that let u to be equal to 4x. So that when we differentiate the u, we have du. So the du we said is equal to 4x. Sorry, 4. Because when we differentiate this, we are going to get 4. Now, what is our v? We said that our v is equal to that is what we integrated to have 1 over 10 bracket x plus 4, then raised to the power 10. Okay, so we are going to substitute all this one into the formula here, so that we can have the integral of uv to be equal to my u. Where's u? U is 4x, so 4x multiplied by v. Where's my v? V is this. So you multiply this one by 1 over 10 bracket x plus 4, then close the bracket, raised to the power 10, minus the integral of v du. Where's my du? My du is what? 4. So we are going to get the integral will be my v is the same as this. So my v is 1/10 bracket x plus 4, close the bracket, raised to the power 10. I'll multiply by my du, which is 4. So all this one is multiplied by 4. Okay, so I can now simplify this one to be equal to, this one multiplied by this. We are going to get let's see, we are going to get 2/10. No, 2/5, sorry. We are going to get 2/5. Then x here. Then open the bracket, x plus 4, close the bracket, raised to the power 10, minus here, I am going to get 2/5 bracket x plus 4, close the bracket, I have 10 here. Okay. Now, remember this, there's integral here. There's an integral function here. So I can say the integral of this. Okay. Now let's take off the integral. Let's integrate the last part. Let's integrate this one. Let's integrate this one. So if you integrate this one, you are going to get, let's integrate only that one. We are going to get, this one will come, add 1 here. So it's going to give us, okay, so it's going to give us 2. Okay, so we are multiplying, because if you add 1 here, you are going to get 11. So it's going to give us 11 multiplied by 2/5. 2/5. So we are going to get 11/5. No. Is it 22/5? Okay.
Sir. Hello, sir. Hello.
Go ahead.
Yes, sir.
Yeah.
Please, I have an issue with the substitution. See, if I look at the formula, the substitution with the formula, it's the integral of u dv, and then we use the outer function to represent u. Now, why didn't you use the inner function to represent v on the other side? But we use the...
Come again.
I said, with the substitution, looking at the formula, the first side, we have the integral of u v, and then with the u, we use the outer function, which is 4x, to represent the u.
Yeah.
Now, why didn't we use the inner function to represent the v?
Why didn't we use the
Inner function to represent the v, but we use the v, that's the integral of v, to represent the v in the first side. So we have the v at both sides. But this one is uv. But when we were calculating, we said we should let v is equal to x plus 4 exponent 9.
Mm-hmm.
So why didn't you use that x plus 4 exponent 9 in place of the v? But we use the one that we integrated the v to represent the v.
Okay.
That's
So
the
if you look
integral
at the if you look at the formula here we have, okay, you see, if you integrate at the end of the day, we are going to integrate the formula too. So this formula that you have here, you see, the formula we have v du here, right? Now, if you have the integral, so it means that we are going to integrate the v. That is why we have to use that one to represent it, the dv that we have. So
yes,
that when we
sir, I know.
integrate, so that when we integrate the dv, we can get the u from it, the v from it.
Okay,
So
so we are
if
not
you
using the v.
no, if you are using the
No.
v, it gets for you to substitute them straight for it. There's no need for you to work again. So you have to use the v to represent that, the dv to represent the whole of that term, and then when you integrate that dv, then you can get the u from it, the v from it. Yeah. So let's see if we finish this one, we can get another example, then see how it's going to be. Okay. So let's integrate this function. Let me bring it here. We are going to integrate this function. What was it? So we are now having dv. Okay, should be equal to 2 over 5x, then bracket x plus 4. Then we have 10 here, minus 2 over 5. Then bracket x plus 4 10. But here there's integral sign here. There's an integral sign here. Okay. Now here when you integrate, I want the v to stand alone. So when you integrate this one is going to get out. So we are having our dv now to stand alone. Our dv now to stand alone. Okay. And this one, we are going to rewrite this one as 1 over 5 x here, then x plus 4, then we have 10. We have 10 minus. Now we are not going to integrate this function. Integrate this function. Remember that when we are integrating this function, this one has to come down. We are dividing whole of this one by this. So at the end of the day, we are going to get 2 over the 10. You are adding 1 to the 10. That will give you 11. 11 multiplied by 5. That is going to give us 55. 55. Then bracket x plus 4 plus 4. Then raised to the power 10. 11, sorry, raised to the power 11. Raised to the power 11. Okay. But because we are at the last point, whenever we are integrating, remember that you add constant. You add constant to it. So this is how we do integration pass. So first, you need to represent the numbers first before you can move on. Okay. So let's see if we can get another example. Then we can go through it. Let's see if we can get another example. Yes, so this is another example. Let's work this one. This is x bracket x squared x cube plus 1. So I'm going to open a new page. Open a new page for us to differentiate it. Okay, so let me delete this. Oh. Okay, so our next example is this x bracket, is it 3x squared? Let me check it. Yes, 3x cube. So x raised to the power cube plus 1 plus 1. Then dx. Okay. So we are supposed to integrate this one by past. So first you need to say that let u to be equal to x, so that when you differentiate u, you have du to give you 1, because when you differentiate this one, you are going to get 1.
Is it the U
Then
or the X? Is it the U or the V?
u, this is u, it's not v. This is u. This is u, it's not v. It's equal to 1, because that is why we are going to differentiate. We are going to differentiate this one to get 1. Then your dv here is equal to the one in the bracket. That is, the one in the bracket is going to give us x raised to the power 3 plus 1. Okay. The formula is that we are going to have this v your dv Okay. Let me just go straight. The formula is you are going to get your dv. Yes, this dv here to be equal to u v minus the integral of v du. Now here you know du here. You know du. But what you don't know is the v itself. And that is why you are going to integrate this one in order to get the v from it. Okay, so here let's integrate this one, the v here. So if we integrate the v, remember the v is equal to so my dv here is equal to x keep plus 1. So I'll put my integral sign there so that when I integrate this one and also put the integral sign here, so that when we integrate this, the v and the dd will cancel off, so that I have my v to stand alone. Then I can integrate this one to get my 1/2, then x keep plus 1 raised to the power 2. So this is what I am going to get for integrating the dv. Integrating the dv. Okay. So right now, after this, after the v has been found, you go back to the formula. Your v is being found. The u has been found. You have to just go and substitute them there. Okay, so you are going to get my u is x, so I'm going to get x. My v is this x keep plus 1 minus the integral of v. My v is 1/2 x keep plus 1 squared, and then my du is 1. So I multiply here by 1. My 1. Okay. So from here you can now simplify it.
Sir.
Yeah.
Please, can you go back to the slides, please? The one that we are solving now. Yes, this is the issue that I was trying to clarify. Looking at the v in here, see the u is x, and then the v, we have the inner function of the constant, that is sq plus 1 into bracket. Yes, so that is the v that we used, and then we came here and then we used the integral of v, the one that we found just now, which is 1/2 into bracket sq plus 1 all squared. So this is what I was trying to say, that see this one, we didn't represent the v at both sides, but the other one represent the v at both sides. That is the integral of the v, the one that we found.
Yes.
Yes.
So here,
but that one,
you see this. Look at here like this. You see this dx there. The dx there is telling you that it's an integral. You cannot represent by v alone. It is not standing. This function alone, all this one is not standing alone. It is standing by something, the x. Every function given to you is the x. It means it
All
is
right.
something you need to do about integration.
All right, sir. So and then I think the v multiplying the u should be 1/2 into bracket s squared plus 1 all squared.
Which one?
The right now that we've substitute the u and the v and then the du into the formula. The latter part, that
Yeah,
is the bottom of the
yes. Yeah. Is it here?
no, the down.
Here.
Yes,
Yes.
please.
So here is squared. Here is squared.
That should be 1/2. So it should be x into bracket 1
Yeah.
over
So
2.
it should be 1/2. Yeah. 1/2. 1/2 should be here. Yeah. So 1/2. So after that, you now have to go to the final stage. We had our dv here to be equal to 1/2 x bracket x cube plus 1 all squared minus the integral of which minus the integral of 1/2 s cube plus 1 raised to the power 2 x. Okay. Now we now have to go to and then integrate this one again so that we can get our function to be a normal function. So at the end of the day, we are going to get 1/2 x here, then x cube plus 3 plus 1 all squared minus. So if you integrate this one, we are going to get 1/4 then x cube plus 1 raised to the power, no, here is supposed to be 6 rather, 6. It's supposed to be 6. It's supposed to be 6, so 6, yeah, raised to the power 3. Then you add your constant c. Okay, and this is how this is also been done. So this is the integration by part. Okay. My hostel name is Alex Hostel. But you come to the B. You know the B. The B. You know the B.
Hello, sir. Hello.
Yeah, I'm back. I'm back. I'm back. So let's look at another example. Mr. Boa. Yeah. So integration by submission.
Henry.
So
Hello.
Yes, sir.
Please, we can't hear anything.
Yes, I know. That is why I was calling. I don't know. His mic is mute. I don't know why.
Oh, okay. Okay.
Hello.
Yeah, hello, sir.
Yeah. Yes.
You muted
So
his mic for like 5 minutes.
okay. So I was saying that we are going to do the next one. We are going to do is the integration by substitution. So here, what we are trying to do is that we are trying to represent the integral function in the simplest form. Okay. So and then we substitute the values back into it. So what we do is here is that we want to make the function that will be given to x. We want to make u to be constant, u to stand alone, so that we can also find our dx. Okay. So here we are trying to simplify the function, and at the end of the day, we integrate the simplified function, then we substitute the values back into the simplification of the function, then we integrate all of them, and that will give us the integration by substitution. So here we are just merely substituting the values, the original values, back to what we have simplified, so that it will be in the form of this. Okay, so when the function is being given to you, first of all, we have to say let u. Now we are going to be using the u, not the vu again. We are going to be using only u, so that the u represent the one that is in the bracket, or in the bracket. Then we differentiate that u, then we make the s the subject. So here our main concern here is finding our dx and then finding our u. Okay, dx du here is the same as our du. The x du here is the same as our du. So if you find the x du, we can substitute it there, then we'll simplify it in order to get our integral function. But there are steps that we need to follow to get this right done. The first step is that when you are given the function, we represent the one in the bracket by u. So first step is that let u to be equal to this. Let u to be equal to this, so that this u here will be it's a function that has an x a bracket that this 3x plus 2 is in the bracket. Okay, so you say let u to be equal to 3x squared, or x cubed plus 2. Now, when you say this, then you now integrate this one with respect to x. The second one is to take the differential of the u to respect to x. Now, because there was the x there, you have to make the x the subject. Making the x the subject, then you cross multiply here and divide, so that you can make the x the subject. That's the third step, to make the dx the subject. Now, the fourth step is that now you will now substitute the u back into the u, and then the du dx back into the original function. Then we integrate the original function to get our what we are looking for. Okay, so with this, it's just a simple step that we need to do to get our integration by substitution. Okay, so let's look at example. Then we can Okay, so let me look at this example. Integration by substitution. Integration by substitution. So let me open new page. There's an example here. I'll open new page. Then we'll see how we are going to deal with it. Okay. So the function is the integral, evaluate the integral 6x bracket 3x squared 3x squared plus 5 raised to the power 4, then the x. And we are going to integrate this one by substitution. Integrating by a part is different from integrating by substitution. So we are integrating this one by substitution. And the first step is that we should say let u to be equal to the one in the bracket here. So we have 3x squared plus 5. Plus 5. Only this, the squared is not the cube, or the cube, the raised to the power 4 is not part, only this. So that we can differentiate this one. So we can differentiate the u over the x. When you differentiate the u over the x, we are going to get 6x. Okay. And then we'll make the x the subject. We are making the x the subject. If you make the x the subject, this one is going to multiply here. This one is going to multiply here. At the end of the day, you are going to get my dx to be equal to my du over 6x. So I have made the x the subject. I said let u is equal to this. So with this, I want to substitute my u to the original function and then my dx to the original function, because here we have the x here. So I have to substitute it back there. So if we do that, we are going to get the integral of 6x here. Here, 3x squared plus 4 is now u. So I am going to get my u here. And remember, the u is raised to the power 4. I'll have 4 here. And then dx. dx is now du over 6x. du over 6x. I am just substituting the values into the original function. Okay, so if I have this, then my function is going to look simple now. U is going to stand alone. So after here, this 6x and this 6x will go away. Okay, so I'll have my u the what? Sorry, my u, then I have u to the power 4, then I have my du. This is now the simplest form as we see in the formula. Like, let me go back to the formula that they were asking you to do. This one, this formula. See, we have now expressed it in this form. U in the u and du. Okay. So after that, we now integrate this one, and then we add our what? Our constant. And that is all about the integral by substitution. Integral by substitution. Where's the, okay. So here we are here. That's all about the integral by substitution. So from here, we now integrate this function here. So if we are integrating, we are going to have the integral. So let's integrate this one. You are going to get u5 here all over 5 plus our c, or you can say 1 over 5. Sorry, you can just say 1 over 5. 1 over 5 u5, then plus our c, plus our c. This is what we do the integration by substitution. Now, after this, remember that we are going to substitute it back into the original function. We are going to substitute it back into the original function. The original function is the integral of 6x bracket 3x squared plus 5 raised to the power 4 x. Now this one has now become, let's go back here. Let's go back here and substitute the values there. And substitute the values there. Okay. So we have 1 over 5 here. What is u? U is our 3x squared plus 5. 3x squared plus 5. And then it's raised to the power what? Now 5. Then we add our what? Constant c. Okay. So this is how the integration by substitution is also done. So you guys need to represent the u, then we differentiate the u, then we make the x the subject, then we substitute them back to the original function. We substitute them back into the original function. Let's look at another example. Let's look for another example. I am going to have the integral of 3x bracket x raised to the power 4 plus 3, and I have 5. Okay. Integrate by substitution dx. By substitution. So let hello, mommy. Walaikum salam. Yeah.
Yes, we are.
Okay. So let our u to be equal to 4 x raised to the power 4 plus 3, so that we can differentiate this one, the u over the x to be equal to, when you differentiate this one, you are going to get 4x raised to the power 3. So that you can make the x the subject. Make the x the subject, because there's the x here. You need to substitute. Making this x the subject, you are going to cross multiply. If you cross multiply here, you are going to get the x to be equal to du over du over 4x raised to the power q. 4x raised to the power q. So this is what we are going to get. Now you know your dx, you know your u. Substitute them back into the original function. Substitute them back into the original function. So at the end of the day, we are going to get the integral of 3x. Integral of 3x. Now, here is now, we say let u is to equal to this. So let's represent this one by our u. So you have raised to the power 5. Then the dx is now du over 4x raised to the power that is 3. Okay, raised to the power 3. So this now I am going to so this, we are going to have this 3x over, let's bring this one there, 4x raised to the power keep 3, and our u here will stand alone. Then our u here will stand alone 5. Yeah. Then my du. Okay. So here again, we integrate the function here. We integrate the function here. Only the u, we integrate the u here. So when you integrate the u, we are going to have the u here. So let's see, if you take the integral of both sides, we are going to get 3x over 4x raised to the power 4. When you integrate the u, we are going to get 1 over, integrate the u, we are going to get 1 over 6, then the integral here, then we have 6, then plus our c. Okay, so at the end of the day, let's this one come here. You are going to get you are going to get 3 over 24 3 here, so 3x over 24 s cube. Then we have our u 6 plus c. Okay, so you can now substitute the u back. We now substitute our u back. The u is given as 3x. The u is given by what we have gotten here. This is our u. Okay. So at the end of the day, you are going to get 3x here over 24 s cube. Then bracket here, x raised to power 4 plus 3 raised to power 6, then plus our c. Okay. So this is how the integration by substitution also takes place. Now, last example. Last example before we go to the next one is we have the integral of 6x then bracket we have done this already. Yes. Wait. Some. When this?
So please, I was not in the house. So I was not in the house. Yes, I'm not even with my hand. I'm not even with my hand.
Your mom asked me.
Say please, yeah, this one, the phone station. I have to see how to do it.
Why do you have to? You don't go to class.
So I go for class every day. I don't sleep. Therefore,
So this time again, you are going to do like the same thing.
no. So this time I perform.
You perform well.
So this time I
Infinite, you have to. Yes.
so you put it, I'm planning, allow me to write my online. The same will look things online. So you don't allow me to write. I went there, explain to them, and say, wow, it's any of things.
I'll call your mother and tell her what is happening. Okay. So we have x, yeah. This is the same thing that we did. Okay. So I have 3x here. Bracket 3 x raised to power 3, then plus 5 raised to the power 4. Then we have my dx. Okay. So again, let my u to be equal to x raised to the power 3 plus 5. So that my du, my dx will be equal to 3x squared. Three x squared. Okay. 3x squared, yes. So that I can make my du the subject or my dx the subject. Making the x the subject, you are going to get the x to be equal to du over 3x cube. Okay, let me bring square here. Let me bring square here. Okay. So that when you have this, we can now substitute the u in there. So I have my integral of 3x squared. Then this one is represented by u. So I have my u raised to the power 4. Okay. Then here is represented by dx. So dx is now du over 3x squared. 3x squared. And so after this, we simplify this, this 3x squared, 3x squared will cancel. So at the end of the day, we have the integral of u for then my du. Okay, now integrate this one. If I integrate this one, I am going to get 1 over 5. 1 over 5 u raised to the power 5 plus my c. Okay, so I have to substitute this one, the u back here, so that I will get my final answer to be 1 over 5. Then my u is x raised to the power 3 plus 5 raised to the power 5. Then I'll add my constant c. Okay, so this is how we do the integration by substitution. Any question?
Two minutes.
Yes, any question? Hello?
Yes, sir, we are here.
Okay, if there's no question, we are moving to the last part.
Hello, sir.
Yeah.
Mine is not a question. I'm in Cape Coast and I want to know where to meet you so that I can get the book.
Cape Coast.
Yes, I'm in Cape
Oh,
Coast
yeah.
now, and I want
Are you close to campus?
I'm very close to campus. I'm at is it Pseudo?
As you do. Okay. Then you just come to science, then call me, I'll meet you.
Okay, sir. Is it the science station or which part?
Yes, the science station.
Okay, sir. Then I'll call you.
All right.
Thank you.
Your name again?
I am Festus Senanu.
Okay. So let's move to the last thing we are going to do for the I don't know if we can be able to finish this because this one is also a lot. But this is not difficult. So I know some of you know this thing already. Okay. So I will be skipping some of the things so that I will go to the most important part of what we need to do. I know you have done matrices before. Have you heard of matrices?
Yes,
Yes,
sir.
please.
Long
Yes, sir. Yes, sir.
Okay, that's good. So this is something that we need to revise on. Then I think it's part of the exam question. So maybe after this, I have to get some questions for you to go and try on. And then you are writing your quizzes next month, or when are you writing your quizzes?
next week, sir.
Next week.
Yes, sir.
Okay. I think it's going to be 20 objectives. I guess so.
Yes, sir.
Yeah.
We are
Yes, sir.
writing quiz next week, and I don't know anything yet.
Yes, sir.
Hmm?
Yes, sir.
Yeah.
So, is it possible to have a sample of the objective questions? Because the
But
last semester,
you have objective question in the material. The material I gave to you.
okay, is it in the book that we are going to buy? Which material?
I have objective questions there.
Okay, sir. Okay, sir.
Yeah. Oh, you don't have a copy. You have a copy?
No, I'm the one that called you that I want to have a copy. So when we are done with the class, I'll meet you.
Okay. There
Okay,
are
thank you.
objective questions there. Then I can even provide more if you want.
And so we will not get any soft copy as well.
Come again.
Please, we will not get
Okay,
any
so
soft copy as well.
soft copy as well. Like how? You have the hard copy.
No, please, I don't have where I am. I'm still reaching to. If I can get a soft copy to help me.
Yeah, you can get some. Contact the course rep.
Okay.
Okay, so here we are going to look at 5 key things, but most of them I am going to be skipping them. Then we'll go to the main thing. What we need here is the important things here is the 4 to 6.
Sir, your
6.
slide is not showing, please.
My slide is not showing. Oh, I've not. Oh, sorry. I've not projected it. I've not shared it. Okay. Can you see it now?
Yes, sir. Yes, we can.
Yes. So here we are looking at definition of matrix definition, addition and subtraction of matrices, multiplication of matrices, determinants of matrices, inverse of matrices, and then Cramer's rule. Now, from 1 to 3 is not something that I am going to do. I am going to do from 4 to 6. That is the most important part of it. So that when you get the slides, you can go through the rest yourself. Okay. So
Please,
yes.
if you can just go them through, because some of us didn't do EMAS back at SS, so we have little knowledge about it.
Okay. So when we talk about matrices, we're talking about it's a a triangular, or it's an array of numbers that are being arranged in a square matrices, or in the square bracket. Okay, and then these numbers that are arranged can be any variable. It can be parameters, it can be numbers, it can be variables, and these are arranged in order. Okay, so it gets an array of numbers arranged in an orderly form. It can be numbers, any number you can think about, parameters, and then the numbers or the elements or the numbers or parameters that you can find within the bracket is what we call elements. And then we have the horizontal part of the numbers is what we call the rows. And then the vertical part of it is what we call the columns. So we have rows and columns in the matrices. So all the numbers or variables or parameters on the horizontal axis or on horizontally is what we call the rows. And all the numbers vertically or all the variables vertically are called the columns. So this is an example of a matrix. We are saying that there are array of numbers being arranged in an orderly form. We can see that it can be in the form of numbers, it can be in the form of parameters, or it can be in the form of what variables. We are also saying that all numbers horizontally are columns. So 1, 3, 1, 3, 2 are columns. And all numbers vertically are, all numbers vertically are what? Columns rather. Let's go there. All the numbers that we have horizontally are the rows, are the rows. So 1, 2, 3 are the rows. And then all that we have vertically are the columns. So these are the columns, these are the rows. The same thing applies to it. So we can have columns by rows or rows by columns. So if the number of rows is equal to the number of columns, we call them square matrices. We call them square matrices. So we have 3 by 3, we can have 2 by 2, we can have 5 by 5, we can have 6 by 6. Okay, and then the elements there, the numbers or the variables or parameters there are called the elements. Okay, so the number of rows we represent it by R, and the number of columns we represent them by C. So by definition or by dimension, we can say that we have R by C dimensions. R by C. R represent the rows. Remember, the rows are the horizontal numbers on the horizontal line, and then the columns are numbers on the vertical line. So we have horizontal versus columns. R represent the rows, and then C represent the columns. So we read it as R by C. The rows always comes first before the columns. Then we can have a simple definition of terms. We have a square matrices. We are saying that in the square matrices, the number of rows equal to the number of columns, like I stated earlier on. So we have column vector. If the matrix comprises of only a single column, then we call them a column vector. Okay, so remember the columns or the rules. Let's look at the rules first. If you have the R by 1, it means that you have only a single what? Rules. Single rules. That is why we have R by 1. And if you also have 1 by C, it means you have a single what? Column. So we can have a vector or rule vector and then a column vector. That is if you have column by 1 or rule by 1 and then vector or column by 1. We also have a null matrices. A matrices, or it is a matrix that have 0 elements or 0 numbers or 0 variables or 0 parameters. That is what we call a null matrix or an empty matrices. You can see all the matrices are 0, 0, 0 there. So when you find that, we call it a null matrices. Then we also have a unit or identity matrices. Identity matrices are matrices which that take the form of a square matrices, where there is zeros in the off diagonal, and then ones in the so there's zeros in the off diagonal. These are the diagonals. Okay, we have the principal diagonal and then the off diagonal. The principal diagonal is from 1 down. 1 to 1 is the principal diagonal, and then 0 to 0 is the off diagonal. So any matrices where you see the principal diagonal represented by 1 1, we call it an identity matrix. We call it an identity matrices. Okay. So this is identity matrices for 2 by 2. This is identity matrices for 3 by 3. You can see that all the principal diagonal we have 1 1 1 2 out. We also have equal matrices. Matrices are said to be equal if they are of the same matrices. Like if they are they have the same, if either they are in the square matrices or whatever matrices they have, they should be in the same dimension. Look at here. Here is 2 by 2 dimension. Here is also 2 by 2 dimensions. So we call them equal matrices. We also have what we call the diagonal matrices. With the diagonal.
Hello.
Go ahead.
So with the equal matrices.
Yes.
Yes. Do we use number of elements in the bracket, or we use the element themselves? Because with this one, I can see they are all having the same element in the bracket, not the dimension, but the same element. So which one are we using?
Yeah, the same dimension, the same element.
All right.
Yeah.
Thank you.
They have the same element, they have the same dimension, but it doesn't necessarily mean that they may have the same element. The elements might be identical, but not the same. Okay. We also have what we call the diagonal matrices. It is a matrix that has 0 everywhere except on the main diagonal. You can see from here, the main diagonal is, or the principal diagonal is the one that we have in the middle. This is the principal diagonal. So when we talk about the diagonal matrices, the rest of the elements are 0 except the principal or the main diagonal. If you look at here, the main diagonal here is 1, -3, and 1. These are the main diagonal. But the main is the main diagonal itself, or the main principal diagonal is the 3. Oh, sorry, the 1. This is the first principal diagonal, and this is the last principal diagonal. So any matrices where there are 0 everywhere except the main diagonal, and we call it diagonal matrices. Then we go to transpose of a matrix. Now, with the transpose of the matrices, we are saying that you have row by column. Okay. If you want to transpose this, it means that the columns become rows and rows become columns. You are interchanging them. You are interchanging them. So you are transposing them. So rows become columns and columns become rows. That is the meaning of the transpose. Okay. And we use this A prime to represent a transpose, to represent a transpose. Okay. For example, here we have here how many rows and columns are here. So we have rows by columns. And we said that with the rows, we are talking about the horizontal, rows are the horizontal, and then columns are the vertical. Okay. So here, how many rows do we have? We have 1, 2. We have 2 rows here. And here, how many columns do we have? We have 1, 2, 3. We have 3 columns. So we call it 2 by 3 matrices because we have 2 rows, 1, 2, and we have 3 columns, 1, 2, 3. We call it 2 by 3 matrices. Now, how do we transpose these matrices? We are saying that the rows become columns and columns become rows. So with this, these are the rows. These are the columns. These are the columns. So we are transposing this. It means that all this one must become vertical and all this one must become vertical. So you turn this row to vertical, you turn this row to vertical. So here you are going to get 3, then 2 will come down, and then 0 will also come here. Okay, this was horizontal. This was the row. Now you've turned it to vertical. That is the column now. And then 6 here will come -6, 0, and then 1. When you do this, then you are transposing. You have changed columns, or you have changed rows to columns and columns to rows. And this is what we call transpose. This is what we call transpose. So you can transpose a lot of variables here. This is 1 by 5 because we have only 1 row and then 5 columns. So we call it 1 by 5, or we call it a column vector. Or row, so yes, we call it column vector. So if we want to transpose this all become vertical. You have to turn this one to become vertical by rearranging them so that the 5 will come top here, then 2 follows, -1 follows, 0 follows, and then 5 -5 follows. So when we do this, then it means that we are changing them to columns. You are changing the rows to columns. You are changing the rows to columns. That is how we do transpose.
So it's 6 that comes
Please,
first.
the first number.
Come again.
The first number is 6, not 5.
Okay. So when you do that, we are transposing them. Then let's quickly look at, so you can have a number of variables you need to transpose. Like I said, this one wasn't, okay, let's see. This is a number. This is a vector, or this is a 4 by 4 matrices. We are going to transpose them. All the rows, we are having 4 by 4 because we have 4 rows. We have 1, 2, 3, 4. There are 4 rows. And we have 4 columns. 1, 2, 3, 4. 4 columns. So we call it 4 by 4 matrices. Okay. Then if you want to transpose this, it means that you have to change the column to become rows and rows to become columns. Okay. So all this one here must turn into vertical. Must turn into vertical. And all this one must also turn to vertical. This one must turn to vertical, and the rest. Okay. So you are going to get this one turn it to vertical. This one you have here. You have 6, 0 follow, 3 zeros. So the 3 zeros will come here and follow here. Then you move to the next one. The first one is 0. This is the 0 that you have. The second one is -2. You are turning it to vertical. -2 is here. And then we have the 2 zeros here. The 2 zeros will also come here. Then the last one, the third one is also 0 start. 0, 0, we have 0 here. We have 0 here. 3, we have the 3 here. And then 0, we have the 0 here as well. Then you can go to the last one. 0, triple zeros, we have the triple 0 here. And then 5, we have the 5 here. Remember, the 5 was on the horizontal. Now it is vertical. Okay, so we are turning columns to rows and rows to columns when we talk about transpose. That is the basic idea now. We have triangular matrices. With the triangular matrices, we are saying that it must be a square matrices where elements above or below the main diagonals are 0. This is the main diagonal. This is the main diagonal. These ones are the main diagonal. If you have elements above the diagonal to be 0, or you have elements below the diagonal to be 0, they will call it a triangular matrices. A triangular matrices, because this one becomes like a triangle. This one becomes like a triangle. So if you want to draw a circle here, you see we have this here, we have this, and we have this. So this one will look like a triangle. Above is 0. Here to here will also look like a triangle. Below is also 0s, and this is what we call the triangular matrices. We also have a symmetric matrices. We say a symmetric matrices must be a square matrices, so that when you transpose the matrices, it is equal to itself. So if a square matrices and A transpose are equal, then we call it symmetric matrices. So it is basically telling you that if you transpose these matrices, you are going to get the original matrix itself. And that's what we call the symmetric matrices. You transpose it and you get the original matrix itself. We call it a symmetric matrices. We have the idempotent matrices. The idempotent matrices. A matrices that reproduces itself when it is being multiplied by itself. So when you multiply the matrices itself, then you get the matrices itself. And that is what we call the idempotent matrices. The idempotent matrices. You multiply the matrix itself and you get the matrices, the original matrices. But the symmetric matrices, when you transpose the symmetric matrices, you get the original matrices. But the idempotent matrices, when you multiply it by itself, or when you multiply it by itself, then you get the matrices itself. Okay. Then we can go to addition and subtraction of matrices. This week, I am just going straight to the examples. Where's example? There's a lot of examples, so let me see. So if five, 6, 4, 3, and matrix B to be equal to 2, 4, 2, 2. Then you are being asked to find A minus B. A minus B. It means that we are going to subtract A and B. So we are going to get 5 here, 4 here, then 6 here, 3 here, then minus 2 here, 4 here, 2 here, 2 here. With this one will subtract this one will subtract this one will subtract this, and this one will subtract this. So at the end of the day, we are going to get 5 minus 2, we are going to get 3. 6 minus 4, we are going to get 2. 4 minus 2, we are going to get 2. And then 3 minus 2, we are going to get 1. So this is matrices subtraction. This is matrices subtraction. If it is addition to the same thing, if you are adding the same thing, you add this one to this, add this one to this, then add 4 to 2, and then add 3 to 2. And we are going to get it at the same time. That is simply what we call the addition and subtraction of matrices. So you have matrices A plus B. So A plus B simply means that we are going to add 1 to 5. Add 1 to 5, add 0 to 1, add 2 to 3. So the first thing, A plus B, we are going to get 6. Then 0 plus 1, we are going to get 1. Then minus 2 plus minus 3, you are going to get minus 5. Okay. Then the second one, we are going to get 3 and 2, 5. We are going to get 2 and 7, 9. We are going to get 1 and 0, 1. Then the last one, 5, 1 is 6. Minus 3 minus 1 is minus 4. And then 4, 3 is 4, 5 is 9. And this is what we call the subtraction, the addition. We are adding them. When you come to subtraction to the same thing, you are going to get 1 minus 5, 0 minus 1, and minus 1 minus 3. And you have to get the answers as well. So this is the addition and subtraction of matrices. Okay. So we have property of matrices addition. We have the commutative matrices. We mean that when we are adding A to B, should be equal to B plus A, because it is addition. Whatever you do, you are going to get the same thing. So these are not anything we are going to worry ourselves about. Let's go to subtraction. Yes, we have done the subtraction. I don't have to waste my time here. Then scalar matrices. These are, let me see. Yes, scalar matrices. Now, when we talk about the scalar matrices, it is about multiplying a particular scale by the matrices itself. Okay, so from here, you see that we have 2A, 3B, 2A plus B, and then A prime, B prime. Remember that when we are doing the transpose of a matrices, we represent it by this. Please take note. This is how we do transpose of a matrices. Anytime you see A prime or any number prime, it means a transpose. They're asking you to find the transpose. We are asking you to find the transpose. So take note. Okay. So with this, if you have 2 multiplied by A and you have the matrices A here, it means that you are supposed to multiply the 2. It's going to be this way. 6, 2, 0, minus 1. You are multiplying the 2 before you can add them, because especially this one. You have 2A plus B. It means that you have to multiply 2 before you can add that to what? The B. So you are going to get 12, 4, 0, and then minus 2. So we are adding this one rather, not the original one. So you have to multiply 2. This is what we call the scalar matrix. The scalar matrices. This is what we are doing. So with the scalar matrices, when we are given a scalar, then you have to multiply the scalar to both sides, up and down, before you can use it to do whatever you want. So with this, for example, we have -3 multiplied by the whole matrices. You multiply the 3 throughout and then put them together before you can use it to do whatever you want. This is what we call the scalar matrices. The scalar matrices. So for example, we have if A is equal to this, B is equal to this, and then 0 is equal to this, or O is equal to this, then we can compute the following. 5A. The 5A means that you are going to multiply 5 to this matrices. We have, so we multiply 5 by this matrices. So you are going to get, if you multiply 5 here, so you are supposed to rewrite it this before you multiply. 1, 2, 4, and then -2. -2. You multiply this one. Yeah. We are going to get 5, 10, 20, and -10. Okay. This is what we call the scalar matrices. Then this one to the same thing, B here. We are going to multiply -3/2 here. 3/2 throughout. So at the end of the day, we are going to get 3/2 here, minus here. You open the bracket. We are going to get, if you multiply 3/2, we are going to get 9 minus 9/2 here. And then here you are going to get minus or positive 12/2. That will give you what? 6. Then here you are going to get -21/2. Then here you are going to get -3/2. Okay. So you are just multiplying the variables inside before you can do whatever you want. So let's take note of the scalar matrices. The scalar matrices. Of course, the solution has been there already. So they can give you a lot of properties to verify the scalar matrices. If you multiply K bracket A plus B, or you multiply the K first before you multiply the scalar, then you are going to get the same answer. There's no way you can get the same answer. Then we move to the multiplication of matrices. With the multiplication of matrices, we are saying that 2 matrices can be multiplied if and only if the number of columns in one matrices is equal to the number of rows in the other matrices. Then it means that you must have a square matrix. You must have a square matrices before you can do a multiplicative. You can do a multiplication matrix. You can multiply matrices. Okay. So the number of columns must be equal to the number of rows for you to be able to do the matrix application or multiplication. Remember that the rows are horizontally represented and the columns are vertically presented. So when the number of columns is equal to the number of rows, then we can use the matrix multiplication formula. Okay. So if we are given this function, matrix A is equal to A11, A12, this is the matrix A. And then matrix B is also given, then we can find A plus B because the number of rows in column A or in matrix A is equal to the number of columns in matrix B. So this one we can find the product simply. We can find the multiplication simply. Okay. Let me go to example if we can get some. Okay, so here, let's see this. If this one we can multiply. We are saying that for you to multiply, then the number of rows must be equal to the number of columns. Rows are the numbers on the horizontal, columns are the numbers on the vertical. So when you see A here, the number of rows, we have 1, 2, 3. We have only one row. One row. And when you come to B, we only have one column. One column. So it means that these numbers can be multiplied. These numbers can be multiplied because the number of rows in matrix A is equal to the number of columns in matrix B. So we can multiply them. How do you multiply them? You are going to take 1 and multiply by 2. So 1 by 2, you are going to get 1 by 2, and then you are going to get 2 by 3, 3 by 3, 3 by 0, and then 5 by 1. At the end of the day, if we are multiplying a column vector by a row vector, we are going to get what we call a scalar. We are going to get what we call a scalar. Okay, so you multiply and add all of them together, then you get your value. Let's go to another one. So this one has been done. So here, matrix A, the first one was we are multiplying A by B. A by B. Okay, so we just multiply this one by this. Now we are multiplying B here by A. If you are multiplying B by A, it's going to be this. We are going to take 1 here, 1 and multiply throughout. So 1, oh sorry, the 2 first. 2 multiplied by, who is there? Huh? Who is there? You want to talk to me? Who are you? Huh? Please just a minute. Okay. So you have to take one after the, you have to multiply them one after the other. Okay, you take 2 and multiply throughout. Then you come and take 3 and multiply throughout. 0 and multiply throughout, and 1 multiply throughout. That is, you are multiplying B by A. But if you are multiplying A by B, it's different. If you are multiplying A by B, you are just multiplying the rows here by the columns. But this time around, we are multiplying the columns by the rows. So multiply 2 throughout. So you are going to get 4 minus 4, 6, and 10. If you multiply the 2 by here, then you come and multiply the 3 here, 3 here. You are going to get 6 minus 3 minus 6, 9, and 15. Then you also multiply the 0 throughout. You are going to get 0 throughout. And multiply the 1 throughout. This is what you are also going to get. So it means that if you are multiplying columns by rows, then you are going to get 4 by 4 matrices. But if you are multiplying rows by columns, you are going to get a scalar matrices. Okay, so there's a lot of example in the multiplication that we can look at. You can look at. So matrix A is given, matrix B is given. How do we multiply this? We are saying that the form is that for you to be able to multiply the matrices, then the number of rows must be equal to the number of columns. Number of rows must be equal to number of columns. So A, how many rows? And then 4, how many? The B, how many rows? Okay, so you are supposed to multiply them one after the other. Okay, now you see, if you are multiplying A by B, then we can simply multiply them, because you have to multiply this by this, this by this, this by this. Okay, then you can't multiply this one by this. If you are multiplying A by B, this one you are multiplying by this. The same thing you multiply by this. The same thing you multiply by this, and you add them up. That will give you the first one here we have. Okay. Then the second one, you multiply this one by this one by this, and this one by this. And then you add them up. This is what we are going to get. Now, what if they ask you to find or multiply B by A? B by A. We are saying that the number of columns in B is not equal to the number of rows in A. So how many columns here? 1, 2, 3. How many rows? 1, 2. In mean that you cannot multiply them. You cannot multiply them. It is undefined. Okay, so whenever we are take note of these things when we are multiplying the matrices. Okay. So there are a lot of examples, a lot of questions you can try. Here we are saying that if A is equal to B, then B is equal to this. Find AT, BT. Here is a transpose. Find the transpose of A, find the transpose of B. After that, we are saying that find A plus B transpose. You add the A and B before you find the transpose. Find AT plus BT, mean that find the transpose of A, transpose of B before you add them. Find AB, multiply A by B before you find the transpose. Then find the transpose of B, find the transpose of A before you multiply them. This is just something that you can do yourself. Okay. So we move to determinants of a matrix. determinant of a matrix is a scalar number or a scalar parameter or vector that we can obtain from the elements of the matrix by multiplying the principal diagonal or by taking the differences between the principal diagonal and the off diagonal. Okay, and that will give us the true character of the matrices. That will tell us whether the matrices, that will tell us the criteria to identify whether the matrices or to identify the dimension of the matrices. So the determinants of a matrix is a scalar number obtained from the elements of a matrix by specific operations, which is a basic characteristic of the matrices. Okay, and we can only find the matrix, the determinants of a matrices by only the square matrices. We can use the square matrices to find the determinants of the matrices. So there are two types of obtaining the matrices. We have the we can have 2 by 2, but there are two basic things that we are going to look at to find the determinants. There are two types. Okay, before I go to the type, if you are given 2 by 2 matrices and you are being asked to find the determinant, what you do is that you take the product of the principal diagonal and subtract it from the product from the off diagonal. Where is the principal diagonal? This is the principal diagonal, and this is the off diagonal. So the difference between the product of the principal diagonal and the product of the off diagonal is what we call the determinant. So what here is that you are multiplying A, if you multiply A11 by A22, and you subtract it from A12 and A21, is what we call the, then you are finding the determinant. So we represent determinants by this. This is the determinant that we are talking about. Okay, so the determinants is pretty simple for 2 by 2 matrices. Multiply the principal diagonal, and then you subtract it from the product of the principal diagonal. So this is what I am just trying to explain. Okay, then for example, here is that if you have a matrices 3 and minus 6, you have 4 and 1, 4 and 1, and you are being asked to find the matrix or the determinant. So the determinants of A, you write this determinants of A is equal to, here you're going to multiply 3 by 1. We are going to multiply 3 by 1. That is going to give us 3. And you subtract it from the product of the off diagonal. That is multiply 4 by 6. That is going to give you minus 24. Minus 24. So at the end of the day, you are going to get minus 3 plus, sorry, it's going to be 3, right? It's not minus 3. It's going to give us 3 plus 24. And that is going to give us what? 27. So 27, which is a scalar, is the determinants of the matrices. The determinants of the matrices. So this is how we calculate determinants of the matrices, by using 2 by 2 matrices. So guess the next one, guess multiply this one, that will give you negative 10. Then you multiply this one, that will give you 0. Negative 10 minus 0 is going to give you negative what? 10. And that is the determinants of that matrices. The same thing can find the matrices here. Here you are going to multiply 5 by 4, so you are going to get 20. And then plus, it is plus because, okay, let me do this. So we are going to get this minus 10, 7 minus 7 multiplied 0.5 is going to give us minus 3.5. Yes, I guess so, 3.5. Yes, minus 3.5. So at the end of the day, your determinant is going to give us 23.5. And that is equal to the determinants of C. Determinants of C. So this is how we find the determinants of a matrices. So now, if you have a 3 by 3, how do you find the determinants of the 3 by 3 matrices? So here, there are two ways of finding the 3 by 3 matrices. One is that we can look at the summation of the 3 product, then we delete the rows. So let me just go straight to how the two type of formula that we use to calculating the 3 by 3 matrices. We have the first method called the Laplace method. The Laplace method. And then the second method is what we call the Sarus method. Where is it? The Sarus method. The Sarus method. Okay. But I am going to look at only the Laplace method. Then maybe when time permits, you can look at the Sarus method. Now, the Laplace method, let me go straight to this, let me see, example, using the Laplace method. I want to copy this to a new page. Okay. So we are going to calculate the determinant here using the Laplace method. That is the method I am going to use for now. Okay, so what it means is that we are finding the determinants of the matrix. First, the first thing is that we need to hold this one constant. Okay, so take, for example, we are going to take 2. If you are taking the 2 here, it means that you have to cancel all the columns on the 2 and all the rows on the 2. Then we have taken 2. So write the 2 first here. We are writing the 2. That is the 2 we have picked. Okay. Now what is remaining is 0, negative 0 here, and 2. Then minus 4, and then 2. That's the first one. Then after taking the 2, you now come and take 3. 3 is next. So you take 3 here, minus 3. Then if you take 3 here, we are going to cancel everything on 3. The rows and columns on 3. Rows and columns on 3. What is remaining here is 1, sorry, it's 1, 2, and then minus 1 and 2. Then the last one is 5. The last one is 5. So you take 5 here. All rows and columns under 5 is also gone. So plus 5. Then you open the, what is remaining there is 1, 0, minus 1, minus 4. Okay. Now you can now find the determinants for each of the square matrices or the 2 by 2 matrices. The first one is 2. So find the matrices here. You're going to find the determinants for this 2 by 2. This will give you 0. So 0 minus, this one was what? Is it 1? The first
4,
one
4.
was minus 4.
It
Is
should
it
be
4 or
minus
minus
4.
4?
Minus 4.
Yes, minus 4. Okay. So you multiply 0 by 2, you are going to get 0. And then minus 4 by 8, you are going to get minus 8. So at the end of the day, this is going to give us positive 8 for the first one. So we are multiplying the 2 by the positive 8 here. Then you go to the 3, minus 3 here. Then you take the determinants of this. 2 by 1 is going to give you 2. Minus 2 by 1 is going to give you minus 2. So at the end of the day, you are going to get 4. So with the 3, you are getting 4 here. Then you close it. Then plus 5. Plus 5. Okay. With the 5 here, you are going to multiply 4 by 1. You are going to get minus 4. 1 by 0, you are going to get 0, minus 0. So at the end of the day, you are going to get minus 4. So here is minus 4. Minus 4. Then you can now multiply and simplify this. You are going to get here 16 minus 12 minus 20. What are you going to get at the end? You are going to get the determinants of the matrices A to be equal to minus 16. Minus 16. Minus 16. Now, one thing to know here is that, you see, with this, I was saying here, the first one I said is plus, is positive. The second one I said is negative. And the third one I said is plus. It depends on here. There's a rule that says that the first one should be plus, second should be negative, third should be plus. So here should be negative, here should be plus, here should be negative. Here should be plus, here should be negative, here should be plus. So we are following this rule whenever we are doing the multiplication. But whenever you are finding the determinant of 3 by 3, the first number here is plus, is positive. The second number here is negative. That's why I brought the negative here. And the last number is positive. That's why I also brought the positive here. At the end of the day, you can multiply to get and simplify. Okay. So this is what we get found. It's got to 16. This guy will get found, get to 16. So this is how we find the determinants for 3 by 3 matrices. 3 by 3 matrices. There are a lot of examples we can find. This is another example. There's a lot of examples you can find. Or you want us to work another example? Okay, so if it is okay, we can move on. Properties of matrix. No, this is not important to me. Okay. Now let's go to the what we call rank of a matrix. Rank of a matrix. Now we are going to use the determinants of the matrices to determine the dimensions of the matrices. When we talk about the rank of the matrices, we are talking about the maximum number of dimensions or independent rows and columns that we have in a particular matrix. For us to be determined that, we need to test whether there are linearly dependent variables or matrices or rows and columns in the matrices. And we need to use the square matrices for us to be determined that. Now, the main determinants of the rank of a matrix is to determine or to identify the determinants of that matrices. If the determinants of that matrices is non-zero, then we can be able to identify that this matrix is dimension this. So we use the determinants of the matrices to identify the rank of the matrices. We use the determinants of the matrices to identify the rank of a matrix. Now, for example, determine the rank of the following matrices. The rank of the following matrices. First, we need to find the determinant first. If the determinant is non-zero, then we can find out that that matrices is 2 by 2 matrices, or it's 1 by 1 matrix, or it's 3 by 3 matrices. That is simply the rank of the matrices. But if you find the determinants of the matrices and the matrices is equal to 0, then you have to move to the next higher matrices to find the determinants again. Now, for the first one here, we are going to find the determinants of this, which means that the determinants of A must not be equal to 0. Must not be equal to 0. If it's equal to 0, then we'll move to the next or the next lower matrices within the matrix. That will be 1 by 1 matrices. Okay. So if we find the determinants of this matrix, we are going to get this multiplied by this, we are going to get 1. This multiplied by this, you are going to get 0. So the determinants of A, is equal to what? 1, which is non-zero. So we can conclude that once the 2 by 2 matrices has a matrices, then the rank of the matrices is 2. The rank of the matrices is 2, because we are dealing with 2 by 2 matrices. So if you are able to find the matrices and it is non-zero, we are concluding that the determinants of or the rank of that matrices is 2. That is what we mean by 2 by 2, or the rank of a matrix. First of all, find the determinant first. If the determinant is non-zero, then we can be able to identify the rank of that particular matrices. Now, what about this? What is the rank of this matrices? It means that we are going to find the determinants of these matrices first. Then we see if it is non-zero, then we can now conclude. If it is 0, then we have to move to the next lower matrices to find the rank. So let's find the rank or the determinants of these matrices. Calculators can be used to find the rank and the determinants very simply. So we find the determinants of these matrices. We take 1 here. We take the first one here. Then we'll cancel this off. We cancel this off. We have 0, 1, we have 4 and 8. Then minus, we take 2. After taking 2, we cancel the 10s in the 2 here and here. We have minus 1, 1. We have 0 and 8. Then we move to the last one, plus 3. Then we have this 3 here will cancel, the rows and column will go. We have minus 1, 0, 0, 4. Okay. Then we can now find the determinants for the 2 by 2 matrix here. 4 by 1 is going to give us minus 4. Here it's going to give us 0. So here we are going to get 4 here. Here we are going to get, here we give you 0. Here we give you minus 8. So minus 2 multiplied by minus 8. And here too, we are going to get 0 and 4. So here you're going to get 4. So at the end of the day, remember here, go to multiply by 3. So at the end of the day, we are going to get 4. 4 plus 16. 4 plus 16 minus 12. Is it 16? Okay. Okay, so here, sure. So the first one is what? This man or this. So it's going to give us 0 minus 4, right? 0 minus 4 is going to give us minus 4, right? So the minus is attached to this. Okay. So you are supposed to get minus 4. You are supposed to get minus 4 plus 16 minus 12. That is going to give us definitely 0. That is going to give us 0. Okay. So it means that when you have 0 for the 3 by 3 matrix, it means that the matrix is not, once it is equal to 0, the dimension of the matrix is not 3 by 3 matrix because the determinant is equal to 0. It is only 3 by 3 matrices if you have the determinant not to be equal to 0. Now, once the determinant is equal to 0, then the matrices is not 3 by 3 matrices. So you have to move to the next lower matrices to find the determinant. So move to 2 by 2 matrices within the matrices. So I can take any 2 by 2 matrices here. Let me take this one, the first one. Take any 2 by 2 and let's find the determinant. Take any 2 by 2 and let's find the determinant. So this 2 by 2 here, I am going to take 1, 2, 0, no, minus 1 rather. Minus 1, 0. Okay, so that I can find the determinants of this. So this becomes 0 here, and this one becomes minus 2. So at the end of the day, I'm going to get positive 2. I'm going to get positive 2. This is not equal to 0. Okay. So I can conclude that the matrices is 2 by 2 matrices, or the rank of the matrices is 2 by 2. Now, the rank of the matrices is not 3 by 3 because when you find the determinants of the 3 by 3, it is equal to 0. So if it is equal to 0, then it means that the matrices is a 0 matrices. The determinant is a non-singular matrices. Okay, so you cannot find the rank of it. Okay, so you have to move with, you have to move to the next lower rank. That's the 2 by 2. Find the determinant of the 2 by 2 matrices. Then if it is equal to 0, then the matrices is not 2 by 2 matrices. Then you have to move to 1 by 1 matrices as well. So this is how the procedures look like. But fortunately on our part, after the 3 by 3 matrix is giving us 0, we have to move to the 2 by 2 matrix, which is giving us non-zero, which means that the rank of this 3 by 3 matrix is 2. It's 2. Okay, so this is what I was explaining on. We find this one, it is 0. Then you have to consider the 2 by 2 matrices. You find the 2 by 2 matrices, it is equal to 2. So we can say that the matrix B has a rank of 2 instead of 3. If here was, if the first one we found, if here was, let's say 6, if here was 6, it means that the rank of the matrix would have been 3, not 2. So if the rank of the matrices fail because of the determinant, we have to move to the next lower matrices and find the rank or the determinants as well. So we can do this over and over again. Okay. Then please, are you there? You are quiet though. Okay. So let's move to the inverse. This is the most important part for me, finding the inverse of a matrices. We can, the reason why we are always interested in finding the inverse is that it can help us find, we can use it to find, it can help us to solve a set of simultaneous equations. So sometimes we'll be given 3 equations, 3 unknown, and we ask to use the substitution method or the elimination method to find the value of x, y, and z. Now the inverse matrices or the inverse matrices can help us deal with this problem easily. So we represent the inverse matrix. It's just a matrix algebra by deriving the inverse. So we use A prime. So when you see A raised to the power negative 1, we are talking about inverse, or B negative 1, we are talking about inverse, or any number here, this, we are talking about inverse. And we can only find it used by when we have a square matrices. There are 2 conditions. First, we can find the inverse matrices only if we have a square matrices, and if we also have a non-singular matrices. That is, if the determinant of the matrix is not equal to 0, then we can find the inverse of that matrix. If the matrix is a square matrices, we can find the inverse of that matrices. And we are also saying that If you multiply a matrix by its inverse, you will get what we call identity matrices. You will get what we call the identity matrices. So you find the inverse of the matrices and you multiply by the matrices itself, you will get identity matrices. Identity matrices, we have all the principal diagonal being 1, and then the rest are zeros. That's what we call the identity matrices. So the inverse matrices is a linear algebra that we can use to perform to solve a simultaneous equations. Now, how do we find the inverse matrices? There's a simple formula that we use to find the inverse matrices. First, we are going to determine, we are going to find the determinants of the matrices, and we multiply by the adjoint of that matrix or the cofactors of the matrices, and that will give the inverse. Remember that we are saying that for you to be able to find the inverse, then the matrix might have a non-singular matrix. It might be non-singular. It also has to be a square matrices for us to be able to find the determinants of or the inverse of that matrices. The adjoint here will pass through a lot before we can have. So this is 1 over A, 1 over the determinants of A. This is the determinant here. This is the adjoint. To find the adjoint, we have to find the minus, we have to find the transpose, we have to find the cofactors before we can find the adjoint. So there's a procedure that we need to follow to find the matrices of the, or to find the inverse of the matrices. Okay, so these are some terms, but let's move to the steps that we need to follow to find the inverse of a matrix. We are saying that before you find the inverse of the matrices, then the matrix should not be equal. The determinants of the matrix must not be equal to what? 0. Must not be equal to 0. Okay. So let's see. And we are also saying that if you multiply the determinants, or when you multiply the original matrix by its inverse, you are going to get what we call the identity matrices. We are moving to the steps involved in finding the inverse of a matrix. Okay, inverse of 3 by 3 matrices. Okay, that is the inverse of 3 by 3 matrices. But the inverse of 2 by 2 matrix is simple. It's pretty simple. What we do is that, let me go back to the algebra here. Okay, now when we are given, we are going to find the inverse of 2 by 2 matrices. What it means is that we need to first of all find the determinants of the matrices and make sure that it is non-zero. How do we find the determinants? We multiply the off principal diagonal by the off diagonal. So A11 multiplied by A22. A11 multiplied by A22 minus A21 multiplied by A12. Yes, it's the same thing. And you are going to get this. This determinant must not be equal to 0. It must not be equal to 0. Okay, so after finding the determinants here, the next one is that now the next one is that we now have to say that let the inverse represent B11. We are now considering the inverse here to find the inverse of the determinant by 2 matrix. Okay, so if we represent B11, B12, B21, B11 as an inverse matrices, then by definition, we are saying that if you multiply this inverse, this is the inverse. If you multiply this inverse, so for here, this is the original matrices. This is the original matrix that we have. And we are able to find the inverse of the original matrices. That is to give us B. This is the inverse now. So it means that if you multiply this inverse matrices by the original matrices, we are going to get what we call identity matrices. Identity matrices. So the inverse by A is going to give you the inverse matrices. Okay. So here we are doing the multiplication to see if it really happens. Okay. Solving now, after multiplying them, we can now solve for A, B11, B2, and then the rest. Okay, this is algebra. Now let's move to the numerical example using the 2x2 matrix to find the inverse. So assuming that we are given this question, find the inverse of the matrix A. Remember that the first thing you need to do is that you need to find the determinants of that matrix first. You need to find the determinants of that matrix first. After finding the determinants of that matrices, then you find the cofactors. Now, there's something we need to know about the cofactors. Let me write this. Before we go to the 3x3 matrices. So the cofactors, we have minus 1 bracket I plus J. I here represent rows. Is equal to rows. And J here is equal to column. It's equal to column. It's equal to column. Okay. Now, if we are finding the cofactors, first, we need to find the transpose first. The transpose of 2x2 matrix. How do we find the transpose of the 2x2 matrix? You see, this is 2x2 matrices. When you find the transpose of this, you are going to get this one will come. Remember, the rows become columns, column become rows. So you are going to get 20. This become 5. So the 5 become this place. Then the next one, this one become the vertical axis. So here we come 6 and 20. 6 and 2, right? 6 and 2. This is the transpose. This is what we call the transpose. Now, after the transpose, we have to apply what we call the cofactors to determine the opposite corner of the signs, the cofactors, by using this formula. By using this formula. Okay, so when you take the first one, it means that if you want to apply that factor here, so the first one becomes minus, okay, the 1 is there, so you have 1 here. Then this is 1 by 1, 1 plus 1. So you have to get 20 or 1 plus 1 for the first one. For the first matrices here, the row is 1, the column is 1. So the up here, we are going to get minus 1 here, then 1 plus 1. 1 plus 1 is going to give you 2. So at the end of the day, you are going to get minus 1 raised to the power 2. And that will give you a positive 1. So at the end of the day, the first one is going to be positive. The first one is going to be positive. The first one is going to be positive. So we have the positive there. Okay. Then the next one is this, 6. Now the 6 here, we have the row to be 1 and then column to be 2. So it means that we are going to have minus 1. 1 plus 2 is going to be 3. At the end of the day, you are going to get minus 1. So here it becomes minus 6. And that's the minus 6 that we have. Here is supposed to be 20. And here is supposed to be 2. That's supposed to be 2. That's supposed to be 20. Okay, so that's the minus 6 that we have. Then we can move to the next one here. Next one. The next one means that we have minus 1 here. We have a column, the row to be 2 rows plus 1 column. At the end of the day, we are going to have minus 1. And that's the minus 5 that we have here. Then we move to the 2 here. The 2 here is the row is 2. Row is 2, then column is 2. At the end of the day, we are going to get 1 raised to power 4, minus 1 raised to power 4, and that is going to give us positive 2. And that is why we also have the positive here. Okay, so after the transpose of a matrix, you have to take the cofactors. The cofactors mean that you have to apply the formula here. You apply the formula, then you are going to get the cofactors. Now, after getting the cofactors, this one is supposed to be 2. This one is supposed to be this. Okay. So after that, you can now find the determinants of the matrices. The determinants of the matrices is 20 by 2. We all know how to find the determinants of the matrices. So we are going to get 20 multiplied by 2. Then we subtract this and this. That will be minus 30. Minus 30. At the end of the day, we are going to get 40 minus 30. That is going to give us 10. So the determinant is equal to 10. Now, to find the inverse, we said that the inverse of the matrices A is equal to 1 over the determinants of A, 1 over the determinants of A multiplied by the adjoint. The adjoint is the same as the cofactors. So here you are going to have 1 over 10. The determinant is 10. 1 over 10 multiplied by the transpose or the cofactor, which is 20 minus 5, and then minus 6, and then 2. So you multiply this one inside. Okay, you multiply it inside. It runs throughout. So here it's supposed to be this 20 and then 2. 20 and 2. So if you multiply the 10 out, then it means that the 10 is going to divide this one. 10 by 2, 10 by 20, or 20 divided by 10 is going to give a 2 here. Here is 2. Here remain the same. Here remain the same. And then here is 0.2. 0.2. So if you divide the determinant by the cofactors, you will get what we call the inverse. Okay, so at the end of the day, the inverse of the matrices A is going to give us 2 minus 0.5, and then minus 0.6, 0.6, and then minus 0 or 0.2. Okay, so we simplify the inverse by dividing the cofactors by the determinants of the matrices. We can do the same thing to this one as well. This one first, let's find the determinant first. Find the determinants of B. Determinants of B is going to give us 21, 28. We are going to get 28. 28 here. 28 minus 10. 28 minus 10. That's going to give us 18. That's going to give us 18. So the determinants of the matrix is 18. Now we have to find the cofactors of this by taking the transpose. The transpose is that we have to, this one will come, rows become columns and columns become rows. So at the end of the day, you are going to get 7 minus 2, and then 5 minus 5, and then 4. Okay. So this is what we are going to get. Now you apply the cofactors formula, that is -1, then I plus j. If you apply that formula, you are going to get, it's going to affect only these ones, the negative. So here we become negative, so it becomes plus. Here too, it become negative, it becomes plus. So it becomes 7, 5, 2, and then 4. Now to find the determinants, the determinant, to find the inverse, so the inverse is equal to, the inverse of A is equal to 1 over the determinants of B. 1 over the determinants of B multiplied by the adjoint. The adjoint is what we have found here. This is the adjoint. After applying the cofactor formula, this is the adjoint. So at the end of the day, we are going to get the determinants, that is 7. We are going to get 7, 5, 2, 4, all divided by 10. All divided by 10. Okay. Then you now simplify it, and that will come 0.7, 0.5, 0.2, and then 0.4. Okay, so this is your inverse of the matrices. With the inverse of the matrices. Okay. Now, what about 3 by 3 matrices? If we are going to look at it using the 3 by 3 matrices, it's the same thing. First, we need to find the determinants of the matrices. We need to find the minors. We need to find the cofactors, and we need to find the inverse of the matrices. Okay. So let's see if we can find it. Using the 3 by 3 method, where's example? Okay, let's use this example. Let me see if I can copy this. Let me see if I can copy this. So we are finding the inverse of this matrix. First, we need to find the determinant. But for the sake of time, we have learned how to find the determinant severally. So I am going to pick the determinants here straight away. Have they found for the determinant? Okay, let me see. The determinant is 26. Okay. The determinant is 26. So the determinants of this matrix. So I'm not going to find the determinants again because I've taught you severally how to find the determinants. So the determinants of A, or just write this. The determinants of this is equal to 26. Okay. Now, we need to find what we call the minors or the cofactors. So first, we are going to have, this is different from the 2x2 matrices. If it is 2x2 matrix, you go straight forward to find the transpose and the rest. But this one is different. You have to find what we call the minors. The minors mean that first, we need to take, like we're doing for the determinants. If you are finding the determinant, you have to take 3, this one. I'm taking the first 3, the 3 first, and cancel this. So if we cancel this, the first minor is 5, 6, 4, and 8. This is the first minor. This is the first minor. And you can find the determinants of the minor. So in every minor, let's find the determinant so that we can be safe. So we are going to multiply 5 by 8. That will give you 40 minus 24. 40 minus 24, the first one is 26. This is the first minor. 26 or 16. Then you go to the second minor. The second minor, I'll move to 1. So if you take 1, you cancel 1, the both columns and rows. You are going to get 2, 6, and then 1, 8. 1, 8. Then you find the determinants of this. You are going to get 16 minus 6. That is going to give us 10. This is gone. Then you move to the next one. You move to the next one, minus 4. So here, the minus 4, you cancel this and cancel this. You are going to get 2, 5, 2, 5, 1, 4. Then you find the determinant. This is going to be 8 minus 5. That's going to give you 3. Then you move to the next one. Here we are going to do for all of them. You move to the next one. Minus, we have done 1. We have done this one. The next one is 2. We are going to 2. So if you take 2, this one will go, and then this one will go. You have 1 minus 4, and then you have 4, 4, and 8. And you find the determinants of this. We are going to get 8 plus 8. That is going to give us 16. No, sorry. This is 8 plus 16. That is going to give us 26. 24. So here is going to give us 24. We are multiplying this by this. That will give us 8. This plus this is going to give us positive 16. So we are adding them. That will give you 24. 24. Then you move to the next one. We are done with 2. We are going to 5. So 5, this one will cancel. This one will cancel. What is left is 3 minus 4, 1, 8. 1, 8. 1, 8. So 1, 8, we are going to get 24. 24 plus 4, that's going to give us 28. You move to the next one. This, you now move to the 6. 6, you cancel this. 6. You cancel this and cancel this. What is left is 3 minus, 3, 1, sorry. 3, 1, 4, 1, and then 4. 1, 4. So you find the determinants of this, you are going to get 11. 11. Then you move to the next one. You have finished the second one. The third one is 1. We are going to do for all of them. So this last one is 1. The 1, you cancel this and cancel this. What is left is 1 minus 4, and then 1 minus 4, 5, 6. Okay. Then you find the determinants of this. You are going to get 6 plus 20, 26. Then you move to 4. With the 4 to, you are going to cancel this and this, so that you have 3 minus 4, and then 2, 6. Then you find the determinants of this. You are going to get 18 plus. You are going to get 18 plus 8. And that's going to give us 26. Then the last one, is 8. So you cancel this and cancel this. What is left is 3, 1, 2, 5. 2, 5. Then you find the determinants of this. You are going to get 15 minus 2. That's going to give 13. Okay. We are done for the minor. So we have how many minors? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now, after getting the minors, you now arrange them according to the minors. You arrange them according to the minor. Let me add another. Where's my distance? Let me add another page. We have to now arrange this one nicely. The first one, I had 10. Okay, the first one, I had 10. So I will write my 10 there. From here, the first one, Oh no, the first one was 16, right? Yes. So the 16. So I'll write the first three, 16, 10, and 3. 16, 10, and 3. So I have 16, 10, and then 3. That was the first one. The second one, I have 24, 28, and 11. 24, 28, 24, 28, and 11. And then the last one, I have 26, 26, and 13. Twenty-six, 26, and 13. Okay. Yes. So that is what we found. It's correct. So that is your matrix now. This is what we have. Now, after this is what we call the minus M. This is what we call the minor. This is what we call the minor. Now, after this, we have to take the transpose of this. After this, we have to take the transpose of this. How do we take the transpose? The rows become columns, columns become rows. That is what we are doing here now. So let's do. We are going to have 16, 10, and then 3. You see that these ones become my rows now, my columns now. Then I have 24, 28, and then 26. No, 28 and 11. Then the last one, I have 26 here. I have 26 here. And then 13 becomes this place. Okay, this is my transpose. Now, the next one is that we are finding the cofactors. The cofactors is the formula that we are going to use. This formula. I plus J. Okay. Now, but if we are dealing with 3 by 3 matrices, always remember that we have plus, minus, plus, minus, plus, minus, plus, minus, plus. Remember this so that you will not worry yourself. Try to read the formula. So the first one is plus. So 16 is there. So here become negative. Here is plus. Here become 10 become negative. Here is plus. 20 become negative. Okay. Here is plus. 11 become negative. And then here is plus. Okay, you are applying this one, or else you can use the formula to also do. You are going to get the same answers. Okay, so if we apply this one, then you have what we call. Yes.
Hello, sir. Please, I
We
can't.
were writing the formula. We like that one, the one that is plus minus.
The formula.
Is it 1? Yes.
Okay.
Is it plus minus?
The first is I have plus, minus, plus, minus, plus, minus, plus, minus, plus.
So like positive for the principal diagonal, positive for the off diagonal, and then the rest are negative. Okay.
You can take it like that. So this principal diagonal is positive, off diagonal is positive, the rest are negative. Yes, you can take it like that. Okay. Right, so if we are able to do that, then we move to the final stage. If we do that, then we are find what we call the adjoint. Remember the inverse of the matrix.
Okay, sir.
Yeah.
So if you are solving such a question in the examination and I get to the transpose, I can just skip all the calculations and then jump to use that formula plus minus plus.
But you have to do the transpose first before you do the plus minus. You have to do the transpose first before you use the plus minus plus minus.
Yes,
That's
yes,
what
yes,
I
yes.
did.
Now, yes,
Yeah.
yes, yes. Now, I'm talking about the cofactors. Yes, I was referring to
So the
cofactors.
cofactor, you just go straight and do. If you can remember, you go straight and apply the plus minus and get the cofactors.
All right, sir. Thank you.
So here again, it's going to be determinant. Then you multiply by the adjoint. The adjoint. What we have done here is what we call the adjoint. It's the same as the cofactors. It's what we call the adjoint. So it means that we are going to divide the determinant by the adjoint, and that will give you the inverse. The determinant was 26. So we are going to divide the adjoint here, which is the adjoint, which is we have 16, and then we have minus 24, we have 26, we have minus 10, we have 28, we have 20, minus 20, we have 3, we have minus 11, we have 13. So the inverse means that divide all this one by the determinant, which is 26. 26. So it means that we are going to take 16 divided by 26, 24 divided by 26, 26 divided by 26, 10 divided by 26, 28 divided by 26, 20 divided by 26, 3 divided by 26, 11 divided by 26, and 13 divided by 26. When we are done with that, that is what we call the inverse. You are able to find the inverse. So please, you have to go follow the steps one by one. Follow the step one by one, and you will be able to get the answers. So this is what I'm saying. This is what I'm saying. Okay, this is what I'm saying. So this become your inverse. This become your inverse.
So how do you get the negative 24, negative 10, negative 26, negative 11?
Okay, we use the formula, but I said that if you don't want, if the formula is complicated for you, just apply this plus, minus, plus, plus, minus, or if you want, you can even use the formula, whichever you want to use. Let me come.
Okay, I've gotten it.
You've gotten it, eh?
Yeah.
Yeah, negative plus negative, and then plus negative plus. This is what we use. Okay. Then before you divide all of them together, this will now become your inverse, the inverse of a matrix. So please, if they ask you to find the inverse of a matrix, this is what they are looking for. There's another example which I might not be able to go through. So
sir, which one
want
are we going to? Hello.
Come again.
Which one are we going to solve in the examination? Is it 3 by 3 or 2 by 2?
Come again.
I said, which one are we going to solve in the examination? Is it 3 by 3 or 2 by 2?
Oh, whether it's a 2 by 2 or 3 by 3, you should be able to do. Which one do you want to solve?
We want the 2 by 2.
3 by 3.
2 by 2.
Ah, you are grown up now. Why do you want 2 by 2? Now let's move to something important before we forget. These are all examples, so please guess. I'll send the slides to you, then you go through it. Now, we can use the inverse, or we can use the matrix approach to find the simultaneous equation. This is what I am interested, because there's a question in there should be a question under this type, so that you should be able to answer it. You see, this is a system of equation. This is a system of equation. Now, sometimes they will give you 3 equations and ask you to find the value of x, y, and z. This one, you can decide to use the elimination method or the substitution method. But the matrices approach has made it very easy for you to find the matrices, to find the value of x and to find the value of y. He has made everything easy for us to do that. So when you are given this function, they ask you to use the matrix approach to find the value of x and y. There are 2 ways of finding it. First, we can use the inverse approach, or we can use the Cramer's rule. The Cramer's rule. I am going to use them, and we are able to find this solution, the same thing. We are going to use the Cramer's rule and then the inverse approach at the same time to find the value of x, y, and z. But one thing you should take note is that this is the basic formula for you to find the value of x, y, and z. If you want to find the value of x, y, and z, then you have to multiply the inverse. You know, this is the inverse. After finding the inverse, multiply that inverse by the final demand function, or the final output. The final output is going to give us these are the final output. 10, 5, and 6 are the final output. And they are going to be arranged in matrix form. So they are going to be arranged this way: 10, 5, and 6. So after you have been able to find the inverse, then you multiply this one by the inverse, and you get the value of x, y, and z. That is what we call the inverse approach. The inverse approach. So let's do that using the inverse approach. Let's do that using the inverse approach. If time permitted, we can also use the Cramer's rule. So I am going to copy this one, and we go straight to find the value of x, y, and z. Okay. Okay, so let me write the function. The first one is x plus 2y minus z to be equal to 10. The second one is 2x plus 4x minus 2z. Then the third one is x plus y plus z. This is equal to 5. And this is equal to 6. Okay. So from here, we need to cast this one into what? Matrix first. Cast this into matrix. Cast this into matrix. Okay. So by casting this into matrices, we are going to get the first one is 1. So we have 1 here. The coefficient, the any number standing alone is 1. So we write the 1. Here, the parameter here or the coefficient here is 2. So it's 2. Here is minus 1. So we write minus 1. Okay, that's the first one, the first equation. The second equation is 2. The third equation is 4. And the last one is 2. Then the last one is 1, 1, 1. Then you close this bracket here. But remember that all these variables, the first one is attacked by x. So you have x. The second one is z. Yes. And the last one is y. Go ahead.
So with the first one,
it
is x plus 2y minus 2.
X
plus 2y minus 2.
X plus 2y
minus 2.
Wow, what I have written is 0. It's the same.
It should be 1.
It's the same thing.
2 minus 2.
Is
The
that
first one is
Lawrence?
No,
Is
the
that
Z is standing alone, so it's 1 minus 1.
this one is Z. It's not 2. This is Z.
All right, sir. I thought it was.
It's Z.
Okay. Okay, you have corrected it.
It's Z. It's Z. Okay. So these ones are equal to. This one are equal to. The first one is 10. The second one is 5. The third one is 6. Now you are able to transform this system of equation into this matrix form. Now, for you to be able to find the value of x, y, and z, then you have to use the formula that x is equal to the inverse of the matrix A multiplied by D. The D here represents the value of x, y, and z. So you find the inverse and multiply by D. That is 10, 5, 6. That will give you the value of x, y, and z. So the problem now here is to find the value of what? To find the inverse. Now, for us to find the inverse, we need to find the cofactors. We have to find the rest, all the terms, and we'll be able to find the value of x. Okay. Which I am not going to go through all this. Once you are able to find the inverse, and the Sorry. The call interrupted me. Now, what I am going to do here is that, please, let's note that I'm saying that if you want to find the value of x, you have to find the inverse of this. You know how to find the inverse. You have to find the minus, find the cofactors, divide by the determinants of the matrices. Then you now, after getting the inverse, then you multiply by 10, 5, and 6. And that will give you the value of x, y, and z. But once we are not, I didn't teach you how to use the Cramer's rule. I am going to use the Cramer's rule because of the factor, the time factor. Let me use the Cramer's rule to find this. Okay. Now, the Cramer's rule says that it is very simple. And I think most of you would prefer that one. The Cramer's rule says that if you want to find the value of x, the first one, x here represent the first column, y here represent the second column, z here represent the third column. I am taking it again. X represent the first column, y represent the second column, and then the z represent the third column. Okay. Now, what we need to do first is to find the determinants of the matrix. Let's find the determinant of the matrix. If you find the determinant of the matrix, you are going to get 16. The determinant of this matrix, let me confirm, is 16. No, it's 10. It's 10. The determinant of the matrix is 10. Now, to find the value of x, we are going to replace, please listen, we are going to replace 10, 5, and 6. 10, 5, and 6 by 1, 2, and 1. And you find the determinants again. I'm taking it again. To find, using the Cramer's rule, you are going to find, we are going to replace this, the first one, by the first column, because you are dealing with x. Okay, so x is equal to, so replace 1, 2, 1, that is, you replace it by the 10, 5, and 6. So you are going to have 10, 5, and 6. Then the rest remain the same. So here you are going to have 2, 4, 1, minus 1, minus 2, and 1. Minus 2 and 1. Then you find the determinants of this again. You find the determinants of this. If you find the determinants of this using the normal approach, you are going to get 52. You are going to get 52. Now, the value of x is equal to the determinants of, let's say this is, the determinants of x. So we are going to have the determinants of x divided by the determinants of the main or the original matrices. That's the determinants of A. The determinants of A. The determinants of x is 52 divided by the determinants of the original matrix, that is 10. At the end of the day, x is equal to S is equal to 5.2. 5.2. I am going to explain this one again. I am saying that using the Kramer's rule, if you want to find the value of x here represent the first column. So replace the final output 10, 5, 6 by the first column, which represent the x. And that is what we have done here. Then you find the determinants of the matrices again. After finding the determinants of the matrices x, you divide the determinant of the matrices x by the original matrices, and that will give you the value of x. That will give you the value of x. Now, let me explain the y. If you want to find the value of y, it means that the second column here represents y. So we are going to replace 10, 5, 6 by 2, 4, or we are going to replace 2, 4, 1 by 10, 5, 6, and find the determinants of the y. After finding the determinants of the y, then you divide it by the determinants of the original matrices. That will give you the determinants of that will give you the value of y. That will give you the value of y. Then again, if you want to also find the value of x or z, this z here, I'm saying that the last column here represents the z or z. So we are going to replace 10. We are going to replace the z column, which is 1, minus 1, minus 2, and 1 by 10, 5, and 6. Then you find the determinants of the z, and then you divide by the determinants of the original matrices, and that will give you the value of what? Z. That will give you the value of z. This is how we use the Kramer's rule to find the determinants or to find the value of x.
So, can we?
Yeah.
Can we solve
Come again?
the first one? Please go back to where we were.
See now, the time is up and I'm tired. I cannot solve anything. You go and solve it yourself.
Yeah, I mean the determinant of 10. Can we solve it first? I'm confused here. Let's see how we got the 10. Whether I'm wrong.
What did you get?
I got 12. So I want to clear my doubt here.
You had 10. 12.
Yeah.
Then please check your calculation. They see. Who else has have tried to solve the determinants? Should be even negative 10 rather. Should be negative 10. Okay.
Please let's go through it and see.
Come again.
Let's solve the determinant for the first one and see.
Okay, so let's go. So they will have 1. Then this and this, we have 4 minus 2, 1, 1. minus 2 minus 2, this and this. We have 2 minus 2 and plus 2 minus 1. Minus 1. So this and this will go. So we have 2 and then 4, 1, 1. Okay, so here will give you 4. So here is going to give you 6. Here it's going to give us this multiplied by this 2. This is going to give you 2. So here is going to give us 4. And then minus, here is going to give us 6. This minus 6. Okay, so here there's minus 2 here, sorry. So here there's 2 here, and then the 2 is multiplying by 4. And minus 1. Here is multiplying by this multiplied by this 2. So 2 minus 4. That's going to give us minus 2. So at the end of the day, you are going to get 6 minus 8. 6 minus 8 plus 2. Is that correct? I've done mistake somewhere. This minus this multiplied by this, that will give us 4. Okay, I'm coming. Let me take my time and do it. This is correct. The 1 is here. So 1 is here. So if we cancel 1 and 1, we are going to get 2 minus 1, 1, 1. Well, that is correct for the first one. The second one is 2. Okay, sorry. Yes, minus 2. Minus 2. Okay, so if the minus 2 come, this and this will cancel. We have 2 minus 2 and 1, 1. That is correct. Then the last one is 1. So this and this also cancel. So you have 2 and 1, 1. Yes, that is also correct. So here you have to get.
So it shouldn't be minus 2, it should be positive 2.
Where?
The second
Yes,
two where
yes, it's -1. Where are you saying it shouldn't be +2? Is it here?
here, where we did the -2,
Here.
the second one.
Here shouldn't be -2.
Yeah, it should be positive.
Why is it positive?
It is positive because of x plus 2y.
Or else we will not get the answer.
X plus 2y. Yeah, okay. Okay. So here you are going to get 4 minus, so
Minus
plus 2,
2.
right? And here 2 bracket. Here you are going to get 2 plus 2. Then the last one minus 2 minus 2, 4. So here you are going to get 6 plus 4, 8 minus, this is going to give us 2.
So to be +2.
Yeah, here is going to be +2, yeah. Is it +2? Yes,
Yeah.
so here is negative. Yes, negative. So at the end of it, we are going to get 2. So you have 16. Is that correct?
And you give us 10.
I'm checking to see, because checking to see the slides. What is wrong with the slides? Okay. Yeah. Then the mistake is the equation I've written. You see the equations here?
It should have been -2.
You see the equations here?
Yes, sir.
Yeah. Equation, I think they interchange them. The first one, you see that here is only z. Can you see this?
Yes, we can. So we've seen it.
But when we were doing the substitution, it became 2 here. So that I was using this one. I was using the first one. Meanwhile, they have changed. They are using this one. So that's the difference here. That's the difference.
Akbe.
Okay. So we are not consistent with the values of x0. Okay, so let's see. If you want to find the value of z here, if you want to find the determinants here, you are going to get you are going to get 4, -2, then 1, 1. Then you have 2, you have 2, a minute, 6. Then if this one comes here, we have 2 minus 2, 1, 1. Then we have the last one minus 2. Then we can have this and this 2, 4, 1, 1. So here is going to give us 4 minus 2, that is 6. Here is 2 minus 2, that is 4. Here is here is 2 minus 2 here. Here is going to be the minus 2.
So it will be positive
Okay.
4.
So at the end of the day, we have 6 plus 8. 6 plus 8
Plus 4.
plus 4. It's the same as the 16, right?
Yeah.
Should be 8. It should be 18, sir.
18.
It's 18.
It's
18.
18.
Is it 18?
Yes,
Yeah,
yes.
it's 18.
18.
Okay, let me check something. Let's do it. 6 minus 8 plus 4. Yeah, so the determinant should be 18 rather. I don't know how they are getting 10. I didn't really
Hello, sir.
cross-check this. Yeah.
Sir, I want to ask a question. In finding for the determinant, especially with the computation, are we to use the cofactors, the formula you gave us, plus minus plus minus plus minus plus minus plus minus minus in the in computing for the determinant?
Just a minute.
All right.
I think I find the determinant somewhere here. Where is it? Okay. What do we do here? What did I use? So 5, 4, 2, 4. Okay. So we have to use the cofactors. We have to use the cofactor. That's the reason why I was using the other minus the other. Where is it? We have to use the cofactors here. Yes. We have to use the cofactors. So here should be minus. Here should be minus. And here should be plus. Okay, but the plus the cofactors is plus minus plus. But if you have negative, the the plus will be defeated. So we still have this. Okay, I think it's, yes, so it's supposed to be this. So that this negative will be there. Yeah.
Hello, sir. We will find
Yes.
the cofactors of the first row. Just the first row.
No, we are not finding for all of them, only the first row. The determinant, we are using only the first row to find the determinant.
Yes, and I'm saying that if you are to find the cofactors, we are finding it for the first row, just the first row.
Yes, get the first row.
All right, sir.
Get the first row. So you use the plus, minus, plus. Yeah. And you find the determinants. So here become plus, here become -2. And here become -2, like it's stated there. So here, if you multiply this one, 2, so it becomes 4 plus 2, that was 6. Here, the -2 is here. And you multiply this one, they'll give you 2. So 2 minus 2, that'll give you 4. You multiply, you're going to get 4 here. And then here too, you are going to also get -4. So at the end of the day, you are going to get 6 minus 8 plus 4. And that will give us minus 14 plus 4. And that's going to give the -10. -10. So they are correct. So we use the cofactors to find the determinant. So it's -10, which is correct. Okay. So there are two ways of finding the value of x, finding the value of y, and find the value of z. Either you use the inverse approach. With the inverse approach, you need to find the minus, you need to find the transpose, you need to find the cofactors. After you find all these ones, then you multiply the final demand or the final output, the x, the final output here. Multiply this one by the index, and that will give you the value of x, y, and z. Now, with the Kramer's rule, you also can find the value of x by taking the determinants of x over the original determinants of A. For y, we take the determinants of y by the original determinant. And then z, you take the determinants of z by the original determinant. Okay. So for you to find the value of the determinant of x, you have to replace the final numbers 5, 6, or 6, 5, 10 with the first column, and you find the determinant. With the y, you are going to replace it with the second column, and you find the determinants. And with the z, you replace it with the third column, and you find the determinants before you divide them. And that will give you the value of x, y, and z. This is where we are going to end our lectures today. I think there are more examples in the book, work examples. So you can also prefer there and then get more examples.
Hello, sir. Please, we will need a slide. Sir, we need a slide. And moreover, seriously, the slide. When I asked the course rep, he said he doesn't have it.
Okay.
Hello, sir.
Yeah.
Sir, please, can you give me your number so that I can meet you right away?
024
024
777
Okay.
5680. You want to come today? Why not tomorrow?
Okay, sir, no problem. I'll meet you tomorrow. Okay, thank you very much.
So, yeah. So if there's anything regarding your quiz, I will communicate to the course rep.
All right.
So I will send the slides to your platform right now.
Okay, sir.